Let's look at Leetcode problem 3, longest substring without repeating characters. So I'll first analyze the statement of the problem, and then I will work out an example. Then I will write a solution for this problem using two-pointer sliding windows. So yeah, for this kind of problem, actually the sliding window solution is the to-go solution. So let's first look at the statement of the problem. So given a string s, find the length of the longest substring without repeating characters. So here the problem is asking find the length, this is the 1 point, and the longest substring. So in other words, we are considering a substring. In other words, it's a continuous piece of s. This is different than looking at a subsequence, which does not require continuous. So here the problem gives us 3 examples and also the constraint. So here the main constraint is that the length of s can be up to 10 to the power 4. So which means if we come up with a solution that is square in 10, it may not pass all the test cases. So here the main idea we are going to use to solve this problem is the following. So let me write here. So the main idea is for each index I, so we find the length of longest substring ending at I without repetition. Characters. So yeah, as long as for each of the index we can find the length, then we just return the maximal of all this length. So here let's look at one example. So let's look at example 1, s equals a, b, c, a, b, c, b, b. So the corresponding index is I equals 0, 1, 2, 3, 4, 5, 6, 7. So let's at index I, when index I equals 0, so the string is a. So the longest substring ending in a and without repetition is 1, right? The length is 1. And when I equals 1, so the string is a and b. So there's no repetition. So the length is 2, right? So when I equals 2, so the string is a, b, c. Still no repetition. Then the length is 3. So when I equals 3, the repetition appears. So it's a, b, c, a, right? It means in the previous characters there is a. So we need to pop from the left until there's no repetitions due to the current index character a, right? We pop this a out. You can imagine in effect we are moving the one of the pointers from left to right. Then we get the length is 3. In other words, the longest substring ending at index I equals 3 is BCA. So without repetition. So the length is 3, right? So when I equals 4, so we get A, B, C, A, B. However, we do not need to start from the very beginning, because if we start from the very beginning, at the previous step, we already have repetitions. So we actually can start from where the last step left. That is, we can start from B. So from here, there's still repetition. Then this repetition is due to the character at index 4. We need to continuous pop from left. Then we pop this B out. So we will get CAB. So this is the longest substring ending at index 4 and without repetition. So the length is again 3. So with the above explanation, let's look at index 5. So we can start from where the last step left, the C, A, B. The index 5 corresponding to C, right? Then there are repetitions due to character C. So we continue continue do the pop. So we get ABC. Then we get the length of the longest substring ending at index 5 and without repetition is 3. So now let's look at index 6. So it's A, B, C, B, right? So we see there are repetitions, then we continue popping A, popping B, and then there are no repetitions. So the length of this substring ending at index B and without repetition is 2. So for index 7, so we are looking at this one. Then there are repetitions, so we pop this C, pop this B, there are no repetitions. Then the length of longest substring ending at index 7 and without repetition has length 1. So overall, the running maximal and the result will be 3. We want to return 3. This is the longest substring. So actually, there are several substrings can have the maximal length. For example, ABC or BCA or CAB. Yeah, actually, in the process, we can print out the substring. In other words, we can easily find one longest substring corresponding to the longest length, or we can return all of them. That's not an issue. But the problem here asks us to return the length. So with this example went over, let's look at the code. So for convenience, I will delete all this part. Recall that we are going to give a solution using sliding window. So as such, we are going to use a dictionary or set, more precisely set, to check conditions. In other words, check if there are repetition characters. So we are using sin, let's say using set. So the result actually we can initialize when let's say answer equals 0. This is just the initialization. Then we can initialize a left. So left is starting at the very beginning. So then we want to, for each index, we are going to find the corresponding longest substring ending at that index and without repetition. So this is a for loop. So for I in range length S, so we're going to check if there are repetitions. So while Si is in sin, it means there are repetitions due to the nearest character we are looking at. Then we just continuously update the left index L. So then we just sin remove the very left, that is L. Then we update L by 1. So once we exit the while loop, then there are no repetitions for string starting from the index L and ending at index I, right? So we add sin to add the Si to sin. In other words, we update the dictionary, and then we check if the length of the longest substring ending at index I and without repetition is greater than answer. If so, we just update answer to I minus L plus 1, right? So after this loop, we have found all the longest substring without repetition at each index. Then we just return an answer, right? So then let's check the special case on this process. Let's also check for this S. Yeah, it's okay. Now let's look at the generic case. yeah, it passes the generic keys. Yeah, one last comment is that for some of the sliding window solutions, sometimes people prefer to write in a double while loop format. For example, for this problem, we can do things like this. Let me copy this one and then change this one to another function name. So then we can do something like this. R equals starting at 0 and n is length of s. Then we can replace this by a while loop. So while r less than n. So if sr is thin, so we just do this thin, then we add sr. Then if r is like this, so we update this. Then after that, each of this one, we just update r1. Then we can check it also passes the generic keys. So this second format and sometimes can be convenient for solving more complex problems. So yeah, we'll also practice some of those problems when we have time. That's it. Thank you very much.